So today we are going to be discussing on natural language processing. So it's going to be more like an overview before we get into getting our hands dirty. Is a nice thing for us to understand what NLP is all about, what are the processes involved, where is it applicable in real life. I would like to begin before we dive into the real the business of the day. I would like to ask this question, and maybe one or two person could volunteer to just give an answer. So we have two texts here. So one of these texts was generated by human and the other was generated by a machine. So you just take like 30 seconds to 1 minute, go through it, and maybe just one person, you can unmute yourself and tell us which of these text was generated by a machine and which of them was generated by a human being. Why do you think so? Any reason? I think you are going too advanced. You are going a bit too advanced. I actually was expecting a reason that a layman can actually flow with. So in response to the quiz, you actually got it right. The first text was generated by a computer, and the second text there too was generated by a machine. This just got to show us that machine or the advances in technology has actually make it possible for machine or computer to actually make humans activities. So in this course that has to do with natural language processing, the goal of it is to actually teach a machine or computer how to speak, how to write, and also how to understand human language. So for today's class, we are going to focus more on the theory part of the NLP. So the theory part is the overview. We just want to familiarize ourselves with what the NLP is all about, the processes involved, its application, and all of that. So in the outline, we are going to talk about the natural language, that is the human language, how it came about, or the evolution. We are also going to look at natural language processing. What is it like? And we are also going to look at the application of natural language processing. Where is it applicable in real life situations? Also look at the components of NLP and why NLP is difficult. NLP, as you see, is not that easy. We are going to see why NLP is somewhat difficult. And of course, we are also going to see the processes that are involved in NLP. Then finally, we'll take a few questions, if any. So I guess someone is about to join us. I don't know if some other person can admit the person. I'm sharing my screen. I can't see it. Is that possible? Hello? Okay, let me admit the individual. Okay, so when we talk of natural language, what is it all about? So the simplest answer to natural language is that it's a human language. So human has this need of communication with each other. Human has involved to the point that they want to interact with each other. They want to share information with each other. So it gotten to the point that human being started with a kind of using symbols and using sign to communicate with each other. And then they now evolved to a point whereby they have to put into writing. Sorry. So human beings have to put into writing this information or these messages that are trying to pass across among themselves. Then we also discover that as we know, every day human beings communicate, every day human beings interact with each other through text. So we have people that have generated text in different formats, that are different ways in which we humans have actually generated text data in the course of trying to communicate with each other, in the course of trying to interact and share information with each other. So due to this, we have a lot of data in text format that have been generated. And according to the industry estimate, over 21% of this data is actually structured. So by structured data, it means data that is well organized. You have it in a well organized form. It's easy for you to access and retrieve and make meaning from it. So we also have over 79% of this data that has been generated that are not structured, so they're in unstructured format. And this data comes from different sources. So we have data that comes from the web pages. We have data from images. We take photos every day. We have data from audios, videos. We do self-feed and all of that. Even our emails is as a source of text data. The chats we do on WhatsApp, on Facebook, Instagram, the social media data, and even anything you can think of that has to do with text. So we have this data that are being generated, and this data are so valuable to us. So you imagine you want to extract meaning from this from data gotten from these various sources, and you find it difficult because first, the data is not that structured and at random places. And if you can actually organize them very well and extract meaningful insight, you can actually make something out of it. So for us to actually make meaning from this text data, we need to organize the data in a format that we ourselves as humans can actually assimilate, then talk less of machines. So for you to actually automate the process, you now rely on a machine to automate the process. And even machine will still need to understand this human language, which is not, sometimes we human, we find it difficult to understand ourselves, talk less of a machine. So this actually gives rise to what we call NLP. So NLP in short is a natural language processing. We are trying to process human language. So that is just the short meaning of NLP. So in the course of trying to process human language, you have to do some things like NLP tasks to make the machine understand. So NLP 2 is also seen as a subfield of linguistic and computer science, which is involved in understanding human language and also writing. So you have different tools or application that is able to generate text. Like when I started with that quiz, and someone was able to actually tell which one was generated by a machine. So you now have a machine. You now give a machine that ability to not just understand human language or speak, but also it can write human languages for us. So we are going to see the application of NLP. By utilizing the NLP techniques, you can actually organize huge chunks of text data and also make meaning from it. So look at this. For instance, we have this is a tweet that was extracted. And if you look at this tweet has to do with some information, actually information about a product. So take, for instance, you are a product owner or a product manager. You have released a product in the market and you want to know how people feel based on your product. Are they happy with your product? Are they not happy with your product? So one thing you could do is you gather all those informations you get from the social platform, let's say Twitter, for instance. You extract all the tweet that has to do with your product, and you now manually go through those tweets to see, oh, are people happy with my product? Are people not happy with my product? But another thing you can also do to automate the process is handing over such tasks to a machine, for a machine to actually analyze the text or the tweet and tell you, oh, if people are satisfied with your product or not. So that part of NLP that is specialized in that is what we call the sentiment analysis. So one of the application of NLP is sentiment analysis. You want to know, are people happy with your product? Are people happy with your services? So what is going on? You just want to analyze text data from a particular platform or source to know people's emotions. So that is one of the application of NLP in real life. So it's in sentiment analysis. So you also have another application of NLP. And one of it is the topic modeling. So take, for instance, you are working in a financial institution and something happened, let's say a robbery took place, and the board of directors wants to know, okay, let's not say the robbery took place. Let's say someone hacked the system and tried to get some financial information, and the board of directors wants to know which documents did these hackers actually make attempts to access. And you are assigned that task to actually tell the board of directors that, okay, it's actually this document or it's actually this email that the hackers were trying to access. So what you can do, or what you can allow the machine help you do, okay, manually, what you can do is you get all the documents that are involved. You begin to label those documents. Okay, this document is related to finance. This one is related to project. I should not bother myself. I should only focus on documents that are related to finance. But what if you hand over that task to a machine and a machine helps you to do those labeling? Then it's not easy for you to filter and say, okay, I'll only review the documents or the emails that are peculiar to a financial transaction. That way you'll be able to tell, okay, which of these documents was the hacker trying to access and all of that. So topic modeling is a very big application in NLP, which is being utilized in real life. The another thing is advertisement matching. I don't know if you have noticed that, let's say you were searching for a particular product or information on Google, and you go on Facebook, you begin to see ads pertaining to that information on your feed. Or let's say you go on a website, you begin to see ads pertaining to information you were searching for on your feed. So what makes that possible is actually NLP. So NLP is able to analyze your search history. The algorithm is able to analyze your search history, is able to analyze your search behavior, and then give the advertisers a kind of a matching words relating to what you have searched for. Therefore, they're able to display an advert in that area. So another good application of NLP is in virtual assistant. This one is very, very common. Most of us, we have used Google Assistant, or for those who are using Apple products, we have probably used Apple Siri to communicate, to book appointments, to schedule meetings, to set alarm. So the technology behind those products is actually NLP and machine learning. Machine learning is like a support, or is it just enhancing NLP in some way. So another good application of this is text generation. So take, for instance, we first started by displaying two text, and I asked which of that was being generated by a machine. So a text generation is the machine or computer actually writing text. So you could come up with an idea, but you are blank. Let's say you are a blogger. You want to blog about news, or you want to write a poem. Now we have machine that can even write lyrics, write poems, write story. So take for instance, you want to write a poem, you know the title of the poem, but you don't know how to come about with the content. Just tell the machine the title of the poem, is able to generate text around that. Though in some cases that text might not be readable, but you can, with little effort, you can edit the text and still get more meaning from that. So that is one of the applications of NLP. But before this can actually be achieved or done, there are things that we humans need to put in place. We humans need to actually do for machine to understand our natural language. So the components of NLP, we have majorly two components of NLP. We have natural language understanding, and we also have natural language generation. Natural language understanding has to do with the computer understanding human language, whereas natural language generation has to do with the computer writing human languages. So if you look at these two components of NLP, then NLU, which is natural language understanding, is very, very, very difficult. It's very, very difficult because unlike NLG is very, very difficult because of how human language is. Human language is full of ambiguity. Take English language, for instance. In English language, we have different types of ambiguity, which could actually confuse even us as human. If there's no context attached to a particular text, you can actually be lost. You don't know what is that text all about. So for instance, in English language, we have different types of ambiguity. We have the lexical ambiguity, we have the syntactic ambiguity, and we also have the referential ambiguity. So what are they all about? So for the lexical ambiguity, it refers to the presence of two or more possible meanings within a single word. So a one word can have different meanings. So that is what it's all about. And if you don't have context attached to that word, you can get lost as to what is the word actually. So it could also be called semantic ambiguity. Let's look at an example. So if you look at those two sentences, focus on the words that are highlighted. So the first sentence says, she is looking for a match. So he left one to be confused. What kind of match? Is she looking for a matchstick, or is she looking for a date mate? So you get confused if you don't have further information or context as to what she's looking for. You will not understand. So if us human find it difficult to understand this kind of sentence, how else a computer? Then the second sentence says, the fisherman went to the bank. Which bank? Did the fisherman go to the bank to withdraw money, or did the fisherman go to the bank to fish? So it leaves you in a state of confusion if there's no context to it. So this is what actually makes it difficult for you to train a computer to understand human language. So for the second ambiguity, syntactic ambiguity, it's actually the presence of two or more possible meanings within a single sentence. So you could have a single sentence having two or more possible meaning. It can also be called structured or grammatical ambiguity, as the case may be. Let's look at an example. So we have two sentences. So the first one says, the chicken is ready to eat. And you could ask yourself, does it mean that the chicken is about to eat food, or does it mean that we are ready to eat the chicken? That is, does it mean that the chicken is ready for we to eat, or does it mean that the chicken is ready to eat food? So you are kind of lost. You don't know what that really means. And the second sentence says, I saw the man with the glasses. So it doesn't mean that you saw a man with the glasses or you use a glasses to see a man. So these are the things that make it difficult for a machine to actually understand human language. So the third ambiguity is actually referential ambiguity. So what is it all about? It actually arises when we refer to something using pronouns. Let's look at an example. So this sentence states, the boy told his father the theft. He was very upset. The boy told his father the theft. He was very upset. The question is, who was upset? Was it the boy that was upset? Was it the theft that was upset? Was it the father that was upset? Nobody knows, honestly, because this is just the ambiguity you find in text almost on a daily basis, that you have to ask for that question before you can actually know, oh, this is what this is all about and stuff like that. So computer needs to get more information, more data. We say in machine learning that your algorithm is as good as your data. The algorithm might be good, correct, but if your data, the data you feed the algorithm is not good enough, you start getting a wrong answers or wrong outputs, as the case may be. So let's also look at another classical ambiguity we might likely encounter. So this ambiguity actually has to do with name entities. The NE there represent name entities. If you look at, we have 1945. What does 1945 represent? Is it date? Is it time? Excuse me. So we also have Washington. Excuse me. Washington. Is it a location or a person's name? Nobody knows. If you don't have further information, you will not be able to know. May. I know some people bear May. So if you find the word May in a text, you are left to ask, does that represent a person or is it a month? So, and you also have Tata. Is it a person or an organization? An organization can bear the name Tata, a person can bear the name Tata. So these are the things that makes NLP kind of difficult. So we also have not just about the ambiguity in a text, we also have styles. The way the text was written, we have the structure, we have the domain. So in this domain, there are some domains that are so technical that you see some technical jargons. So that also makes it difficult for even the machine to understand that, okay, like in petroleum engineering, we have a component called nipple. So it's actually, when you say it, especially in public, it sounds somehow, but if you are in that domain, you know what that really means. So these are the things that could also confuse a computer. So even the punctuation in words, the spelling, we have American spelling, we have British spelling, spacing, formatting, and all of this actually impacts how the computer understands human language. So let's look at the processes involved in making a computer to understand human language. Before you actually make a computer to understand human language, there are things you have to do. So first, this data, like I said before, this data, they come in unstructured format. You have to do some pre-processing. You have to do some cleansing of the data and make it in a way that the computer can actually assimilate. So what are these processes involved in natural language processing, or what are the pipelines in natural language processing? So the pipeline in natural language processing, you could see the segmentation. We have a tokenizing, stop words, stemming, lammatizing, POS tagging, anyhow, and all of that. So the first segment here is more of pre-processing. You have a text data, or you are presented with text data. Before the algorithm can even understand and derive meaning from that text data, you need to present that data in the way the algorithm can actually take in. we humans, we can read text data, but computers, they actually understand binaries 0 and 1. So if you feed a computer with a text, computer does not know what that text is until you convert that text to something meaningful, something the computer can actually understand. So this first part of this pipeline is the processing or pre-processing of the NLP tasks that actually make it possible for your algorithm to take in the input. You can't just get a text data from anywhere and pass it to your algorithm and expect your algorithm to perform magic. That will not happen. So you have to first process the data in a way that the algorithm will understand. So, okay, this is what this means, and this is what I have to do. So let's look at what these guys are, one after the other. So for the segmentation is actually you splitting a document. So you could have a document, or you are presented with a document, and you are actually breaking down this document into its consonant sentences. So usually you rely on punctuation. So if I see a comma, I break. If I see a full stop, I break. If I see a question mark, I break. So by the time we are going to go into practical implementation of NLP, you see what I'm talking about by this splitting. So let's look at an example. So we have a sentence here. Cricket was invented in England, supposedly by shepherds who headed their flocks. Wow. So for you to actually do a segmentation, you have to break these sentences down into break this document, assuming this was a document. You could have multiple sentences in a document. So you have to break it down into their various sentences. So let's see how this can be broken down. So you have cricket was invented in England, supposedly by shepherds who headed their flocks. Yeah, you have successfully broken this down, but you can't feed the algorithm with this as it is. You still have to continue with the pre-processing. So the next pre-processing has to do with tokenization. So what is tokenization all about, Seth? So it is actually done. The reason we do tokenization is so that we can actually understand the syntactic or schematic that is contained in a sentence. That is why we have to do tokenization. Then also, you also have to be able to tell the algorithm what each individual words represent or mean in a sentence. So that is why we have to carry out tokenization. So I want to tell the algorithm, what does cricket means? What does was means? So to actually carry out tokenization, we break down a sentence into their consonant words. So we have cricket was invented in England. So this is how you break down a sentence into their various words so that the algorithm can actually understand what each individual words represent, and so that you can also understand the syntactic in the sentence. So let's look at the next. So the next task you have to do as an NLP engineer is actually the first or the third task you have to do in the pipeline is actually to remove stop words. So stop words are actually words that are not really relevant for you to actually make meaning from a sentence. So if you have a sentence that contains words like it contains words like and, they, or, those words, even without those words, you could actually read that document and still understand it. So we want to train the algorithm faster. As a child, if you remember when you were a child, or if you have a child, when you train the child how to speak or how to walk, you want to make the child learn faster. So in order for us to make our algorithm learn faster, we have to remove these stop words because they don't actually add meaning to the sentence. Instead, they're just there to maybe make the sentence more cohesive rather than adding more meaning to it. So what we do is to remove them. And in the in the course of our class, we are going to see how we remove stop words from sentences. So the next task there is stemming. Okay, so stemming is actually removing prefixes or suffixes from a sentence, or from words rather. So the idea is that you want to explain to the algorithm what this word is. So we have example there, we have consultants, consulting, consultants, consultative. Yeah, this means different things depending on the suffixes and the prefixes they have. Sorry, let me admit someone. Okay. Okay, so we have what like consultant. So depending on the suffixes and prefixes, they could mean different things. But the algorithm does not want to be concerned with those different meanings. The algorithm is interested in the root word, in the root meaning. What this consultative, where was it derived from? Which root word was it derived from? And stuff like that. So now that we have the base form of the text or our document, you want to explain to the machine what this word is actually is. So what you do is you just strip off all those things. So in the course of our training, you will see the algorithm we use to strip off all this stuff, and you will even learn how to do it even with that algorithm, how to remove all the prefixes from text. Of course, you have to know how to program in any programming language. That way, that is the only way you can, programmatically remove these suffixes from words, so that we could just work with the base word or the root word. So the next task is actually to do a lemmatization. Lemmatization is similar to a stemming, but the key difference there is that lemmatization rely on a knowledge, or do I say a dictionary kind of. So the key difference is that it uses knowledge system. So grammatization does not just remove the suffixes or prefixes. So it actually look at the dictionary or a knowledge base to see, okay, these different words, what is the kind of the primary meaning for this word? What is the lemma? They call it lemma. So you have example here, went, going, gone. You want to make your algorithm understand that went means go, going means go, gone means go. So your algorithm is actually left with what go. So when your algorithm sees something like went, it knows that it represents go, going represent gone. And there's one technique we call substitution. So in the course of this training too, we also see how we can apply substitution to actually make, because these words, this went, going, gone, is something that is available or present in the document. And what the algorithm knows is go. Algorithm does not know anything like went. It does not know anything like going or gone. The only thing you understand is go. And then the user now type in went. So you want to make sure that the algorithm knows that, oh, went represents go, or going represents go. So there's one technique called substitution. And in the course of this training, we are also going to see how we can do those substitution and stuff like that in the course of pre-processing the data for the algorithm. So the only difference with lemmatization and stemming is that lemmatization actually depends on a knowledge system or a dictionary. It does not just see a word and trip off their prefixes or trip off their suffixes just like that. No, it has to rely on something to know, oh, this thing, this is what it is, or this is what it means, and stuff like that. So the next thing we are going to look at, okay, before we look at the next thing, so this is just what the two guys represent, the stemming and the lemmatization. So for a word developed, so there's an algorithm called Porter-Stemmer algorithm, which I'm going to show us in different languages. It's actually available online. it's written in different languages. I'm going to show us how that looks like. So what it does is, if you look at the word developed, develop, developing, development, it three parts, the ending, the suffixes, and you are left with the word develop. So this is actually performed using a Porter's stemma algorithm. So if you look at the right-hand side, we have lemmatization. So you have different words like drive, drives, drove, driven. So this actually use WordNet lemmatizer. So WordNet is like a dictionary hosted in the public domain archive. So it uses that to understand that, okay, if I see the word drive, it means drive. If I see the word drives, it means drive. If I see the word drove, it means drive. If I see the word driven, it means drive. The algorithm does not even know this in his knowledge base. It does not have these guys here. I don't know if you guys can see my mouse movement. So it does not even have these guys here. What it has is this guy. So it's now relying on this knowledge base, more like a dictionary, to now say, okay, if I see this, substitute it with this and stuff like that. So the next component of the pipeline is the part of speech. POS for short, part of speech tagging. So what it does is it identifies which part of speech a word belongs to and tag them based on, our own normal part of speech we have in English. So what are the important, why do we have to do part of speech tagging? So the important is to understand the meaning of a sentence or to build a knowledge graph. So you want to build, you have sentences. So you want to let your algorithm understand that, okay, this word in this sentence is a verb, this is a noun, this is that, and stuff like that. So the reason I'm actually going to show you how this is important. So the reason is that some words could actually have a different meaning depending on the sentence. So let me just show an example. So that our former example, this is cricket was invented in England. So what's the part of speech in this guy? We have cricket and now was a verb, invented a verb in a preposition, England and now. So how important is this guy? So this is the importance. So you could have this word like answer. So answer here could mean a noun or could represent a noun. It can at the same time represent a verb, depending on the sentence or where it's being placed in the sentence. So this is very key when you are doing your POS or a part of speech tagging. You want to tell the algorithm that, okay, if I see answer in this kind of sentence, give me an answer. It's more like a noun. Give me an answer. So if I now say, answer this question, that answer now acts like a verb. So if you did not properly tag these words in a sentence, in Nigeria, they say, Oyo is your case. Definitely, Oyo is your case if you don't do that. So what next do we have? So we have name entity tagging. So name entity tagging is similar to POS, part of speech tagging. But in this case, what we are tagging or what we are concerned about in terms of tagging is proper names. So you want to be able to tag a person, you want to be able to tag the quantity, location, blah, blah, blah. Google Map is able to tell you your location because it was tagged as a name entity and stuff like that. Google Map is able to tell you an organization. Google Map is able to differentiate Tata from a person and organization. Google Map is able to differentiate me from a person's name and not Google Map, Google algorithm, from a person's name to the months in the calendar and stuff like that. So this is possible because the name, the proper name is actually being tagged and all of that. So if you look at the other things we have in the pipeline is the NER, That is name entity recognition. So those other parts, let me just quickly go back to that guy. So these other parts here from NER, this is where you say, okay, Oga machine, I'm done with my own task. Oh yeah, take over. So this is where machine learning algorithm comes into play. And in the course of this program, you are going to see how first you process this text using this pipeline or using this NLP tags. You process it. Then we now hand over to the machine learning algorithm and say, okay, it's time for you to act on it. It's time for you to reason. It's time for you to understand what we have been able to tell you, to understand it and give us an answer, stuff like that. So from here, we now have the machine learning algorithm is applied. We have the classifier algorithm. We have a naive-Bayes, most commonly used algorithm. We have a CNN, neural nets, and all of that, k-nearest neighbor, all the machine learning classifier algorithm you can think of, you can apply them here. So the ultimate goal is you have labeled, you have processed all these guys. We are now telling the algorithm, okay, learn from it, learn from what I've taught you. And if information comes in this format, this is what I want. So, and how machine learning is actually different from a rule-based. Before the machine learning, this was actually possible before machine learning. Machine learning is only kind of enhancing the existing in the implementation. The existing implementation was you as a developer or as a programmer, you manually had code those things you want the computer to do for you. So like all these things, NLP end-to-end can be done using rule-based, using hard coding. But the problem with that is that it does not scale. If you can only hard code or do rule-based for small projects, small problems, but by the time the project grows or the problem grows, you now realize that you cannot rely on rule-based completely. You need a machine to automate the process for you. So in rule-based, you write step-by-step process and say, machine, do this, do this, do this, do step A, step B, step C. But in machine learning, you are not doing all those things. You are not writing step and telling the machine, do step A, step B. In machine learning, what you are doing is that you give the machine data and they tell the machine, this is the outcome I want. The machine will now find the most optimal way to give you that outcome. So it's more like you handing you are not, if you check online for definition of machine learning, they'll tell you that machine learning has to do with a computer not being explicitly programmed. So what that means is that you don't kind of program it in a way that you would normally program all those step-by-step logic. What you do is you just, after you are done with your model, of course, you have to write the algorithm for the model. After you are done with it, you now feed it with data and allow the machine to learn with your data. And then from there, it can be able to, give you an outcome. You are telling the machine, I need A. I don't care how you are going to do it, but I need A. The algorithm will now say, okay, let me look for the most optimal way to give this guy A. So that's how it works. So in this course, we are also going to see how you can apply machine learning to do our develop our spam detector and stuff like that. So another thing here is data extraction. Now that the machine has understand what you have said, now that the machine has listened to what you have said, it needs to talk back to you. The machine needs to reply you, the machine needs to respond back to you. When you are chatting with Siri or Google Assistant, you say, hey, Google, what is the time? Of course, it will reply. So for the assistant to actually reply you, this is where the energy comes into play, natural language generation. This part is not that difficult compared to NLU, like I showed us, due to the ambiguity and all of that. So this part is the machine will have to extract data. For instance, now, if I tell Google Assistant, what is the time now? he will have to check for time. After he has understood what I said, the next thing is he wants to extract, he wants to look for time, he wants to check the time and tell me what time it is. So in some other cases, depending on what scenario you are applying it to, you have your data stored in the database or wherever it's being stored. The machine needs to go and extract that data. Then when it extracts that information, it needs to present it to you in a way you can understand. Machine knows 0 and 1 binaries. If you extract that information and come and present to you binaries, you will not understand. Just say maybe you are that techy, you will not understand. So machine will also look for a way to present it to you in a way that you or we human can understand. So there's what we call data transformation. You have extracted the data, you have to transform it in a way that human being can also understand you. That is the machine now. So after you have transformed the data, or the machine has transformed the data, it has to respond. It has to tell you, oh, I'm done. Oh, this is what you asked for. So it can either tell you in text format, or it can tell you in voice. So we have voice assistant, we have voice recognition engines and all of that. So if you want the machine to tell the user, the end user in voice, you implement that. It's going to output the results in a audio format. If you want it to tell it in text, you implement that. It's going to tell you. So at the end of the day, you guys are happy, the machine is happy, and you are happy. So the output there is what the end user sees and is satisfied with the outcome. So that is this part. I was not able to just put things together for us to see how NLG is actually implemented. But in the middle of this course, we are going to see how we can implement NLG, that is computer talking back to human beings. So what's next? This is just an overview of what we are expecting to, or what we'll be doing in the course of this program. So the next thing now is, that is for next week. So the next thing now is to get our hands dirty. All these talks I've said, all these NLP talks and blah, 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 how is it done? How do we get our hands dirty? How do we play around with it? How do we make our computer understand us? How do we make our computer talk back to us and stuff like that? So if you look at the syllables I sent, we are going to see what we have in store for next week. So next week, we are actually going to get our hands dirty. So for those who do not have a computer, I think this is the right time for you to start looking for a computer. Then if you have a computer, get a Python installed, get this thing too installed, C#. I'm more comfortable writing programs in C# than Python. I use Python for prototyping most of the time. But if I want to do real implementation, I go with C#. So I write most of my program in C#. So most of the algorithms or the logic we are going to be writing will be written in C#. So if you can install Visual Studio, or you maybe look up online how you can run a C# program with Visual Studio Code, I'm actually going to be using Visual Studio Code for that, and instead of instead of spending time to trying to set up the environment for Visual Studio, we are just going to be focused with Visual Studio Code. Sorry, there are two different things, Visual Studio and Visual Studio Code. So we are going to be using Visual Studio Code for this, both for Python programming and C# programming. Then if you have done so, you can also go back and look at these things we have discussed. What are they? Go dig deep to try to understand it in details. Okay, this guy mentioned POS. What is POS? What is part of speech? This guy mentioned stop words. What are stop words? Why do I even need to care about it? This guy mentioned tokenization. What is tokens? Why do I even need to bother? Do I need to do tokenization before machine can understand what I'm saying? So before we convey again next week, so just use this time to read those things in there. Try to understand it. If you have a question, our channel is open. The Slack channel is open. Ask your question, will be available to respond to your question. So in this course is more like a collaboration. I also learn from you guys, learn from me. Nobody's is a body of knowledge. We all are learning. So if you maybe have discovered something that is worth sharing with the house, you could drop it in the Slack channel so that everybody can also benefit. So with that much ado, I've come to the end of this class. So this class was more of an intro to what we are going to be doing from next week. So just an overview, getting to yourself familiarized with these things, how they work, and the technology behind those things. We are going to look at that from next week. So in case you want to reach me personally, I'm available. Oh, sorry, it's not my phone number. So I'm available, though I hardly read emails, but you can still send me an email if that is the case. But I'm very, very active on LinkedIn. So you can always check me out on LinkedIn, drop me a message. I'll be there to respond to your message. So the WhatsApp number that you see is actually my number, the one I'm using for WhatsApp. This is not my number. So you can also reach me on WhatsApp as well. But if you have technical questions or discussion, I would prefer we have it on the Slack channel so that others can learn as well. So thank you very much for your audience. I'm really grateful. I'm very, very excited to take you guys on this course. And I hope that in the end, we all learn, and not just learn, we'll be able to build stuff with the skills we have acquired. So thank you very much once again. I remain John Answer by name. Okay, it's time for Q&A. In case you have question, Q&A is open. The channel is open. Please ask your question. Thank you, thank you, thank you.